Hello everyone. Today we are going to talk about computer memory management. Under this, we will talk about the problem with memory management, page table concepts, and framing concepts. If you still not subscribe my video channel, please subscribe now. As well as don't forget to click bell icon as well. Now, this is my computer. You have a computer, I have a computer. And here you have a 1 TB hard disk or more than that, and 2 GB or more than that VG obviously, as well as RAM might be 8 GB, 4 GB, 16 GB, and you have a i3 processor, i5 processor, whatever, and monitor, keyboard, nice joystick with mouse, everything. And then after that, there's something called operating system. Might be Windows 10, Windows 8, Ubuntu, Linux, whatever. And then application softwares. That's depend on your requirement. Might be you with Microsoft Office, Photoshop, whatever. Now, in my computer, there's something called operating system. And then I have a hard disk. And then RAM. And then i3 processor. Might be different. Now let's think. What do you mean by 32-bit? What do you mean by 2 GB hard disk? RAM? What do you mean by 1 TB hard disk? That is capacity. On the operating system, you have something called 32-bit. That means the one moment operating system can handle 2 to the power 32-bit address space. But earlier it might be 16-bit, and also you might have 64-bit operating system as well. And then you have 1 GB RAM, or maybe 8 GB RAM, maybe 16 GB RAM. What do you mean by that? So that means RAM capacity is 2 to the power 30-bit address space. That's depend on your RAM capacity. Fine. Let's start with small example. My operating system is 32-bit operating system, and I have 1 GB RAM. Now for example, as I mentioned y'all, 32-bit operating system means one moment it can handle 2 to the power 32 bits address space. But if I have a 1 GB hard disk, 1 GB RAM, that means it can access one moment 2 to the power 30 address space. Now let's see. I want to load small video file. Capacity might be 200 MB. So very simple. I do the address mapping. I'm going to load into my RAM. Fine. No problem. It's working perfectly. You can watch video. But look at this. What happened? You're going to load more than 1 GB video clip or program. Shall we say about 2 GB video clip you want to play? Now let's see. I'm going to load. Now my RAM capacity is over. What happened next? There is no RAM capacity for load my program. Therefore, your program will be restart. And then there will be another problem. Now I increase my RAM capacity. But I have one program that is it's required 1 GB RAM. And my second program that required 2 GB RAM. My third program also need 2 GB RAM as well. I have 4 GB RAM capacity. Now, first what I am doing is I am loading my program 1 into the RAM. Yes, 1 GB RAM capacity is gone. And then I start with program 2. It's need 4 GB RAM capacity. Now you can see it's loaded, it's working, and then I have a 1 GB free. Therefore, I can't run program 2. Why? Because there's no enough memory capacity. It's waiting. And after few minutes, program 1 is over. Now what happened? Still program is running, but its address space is middle in the memory address space. And you can see you have 2 GB free space, but it is not continuous memory space. Therefore, program 2 can't load into the RAM. Now, the problem is even though I have a free space, if it is not continuous memory space, then that program 2 can't run. Now let's see, I have another problem. Address the same memory location by more than one program. Now let's see, look at this. So one program that is used for gaming, and then second program that is used for bank application. So I write my game results in my RAM, write 1001E 50,000. Both programs are working independently. And then I'm running my program 2 and it shows my bank balance. So it's write W, that means write 1001E and my bank balance is 10,100. So what happened? Previous value is override. And next, again I start my game. But the results, because it's going to read again same memory location. But it's not 50,000, it is 10,000 and 100. So value is incorrect. Now, what the solution I can give? Look at this. Same example, I have a 32-bit operating system and I have 1 GB RAM. Look at this. This is my 32-bit address space. So this is my 1 GB RAM that's having 2 to the power 30 addresses. And also I have a hard disk here. Now there's a table that's going to map virtual address into the RAM address, that means physical address. Now look at this. I'm going to map A1 location into R2. So the mapping part, connection part is done by the table. And then again R2 address that's mapped with R1 and A2 address it's mapped with R3 and then A3 address that's mapped with R1. Now you can see my RAM space is finished. But I want A4 also, but I don't have RAM space. Therefore, I stored in hard disk. Now look at, even though I don't have enough memory space, I can run my program smoothly. Why? Because I'm writing in the hard disk as well. Now Look at this. This is virtual address. This is physical address. This table we call as page table entry. And then now I want to read data from table. This is my processor. This is my table. And then this is my RAM space. Now I want to read R, I want to read A2. Where is A2 located? It is in R3. I can easily map in page entry table. And then this is R3 value. Now look at this. I am getting the value. Now, before we move into the exercise, can you remember we had three problems? Yes. The first problem is there's no continuous memory addresses. And the first one is not enough memory space. And third one is access same memory location by more than one programs. Now think how it's going to avoid using this mapping table concept. These are the exercises you have to do. And in my next video, I will explain how to solve this problem using page table entry method. Alright, see you soon with next video. Thank you.